Okay, so our notes today are on linear equations, and our objective is going to be to write an equation of a line given its slope and a point on the line. Our language objective will be to define 3 different forms that we can write our linear equation in, so slope-intercept form, point-slope form, and standard form, as well as our x and y intercept. So let's start by going over the different forms we can write our linear equations in. So we know slope-intercept form, we worked with that last class. It's y equals mx plus b, where m is our slope and b is our y-intercept. So we're pretty comfortable with this, so I'll just breeze through it. But we use this when we know slope and the y-intercept. So b is our y-intercept, m is our slope. So if we know those two things, we should use this form. The next form that we talk about is point-slope form. So we'll use this quite a bit today. But this is the y minus y1 equals m times x minus x1. And m, again, is just our slope. y1 and x1 are coordinates of a point on the line. So again, we'll put a star here, y1 and x1, or x1 comma y1 are coordinates on the line. And we're going to use this when we know slope and a point on the line. Or 2 points. Because if we have 2 points, we can solve for slope, and then we'll know slope and a point on the line. The last form we're talking about is standard form. And this is ax plus by equals c, where c is a constant and a and b are coefficients of x and y. It's important to know a, b, and c are real numbers. A and b cannot both be 0. And conventionally, so your book doesn't emphasize this, but I'm going to make a note because I'm sure other teachers will tell you this down the line, but a and b should be whole numbers. And a, if possible, should be positive. So this standard form, we're never going to start with, or we're never going to look at a line and plug it right into standard form. We're usually going to plug it into slope-intercept or point-slope form and then rearrange it into standard form, which we'll practice in one of our examples today. But usually if we are going from a graph to an equation, we're going to use one of these two and then rewrite it in standard. So we're going to do an example next with point-slope form. I want us to write an equation for the line that passes through. The points 3, 2, and 5, 8. So we're going to use point-slope form to do this, and we're going to first solve for slope. So we have 2 points on our line, so if we look back at our thing, we're going to use the point-slope when we know 2 points on the line. So we're going to solve for slope. So if I label my points, I have 3, 2, and 5, 8. I'll say x1, y1, x2, y2. So m is going to be equal to 8 minus 2 over 5 minus 3. If I simplify that, I get 6 over 2, which turns out to be 3. So my slope is 3. And now all I need to do is substitute that into point slope. And what's nice here is since I have 2 points, I can use either of them when plugging into point slope. So we have 2 possible equations that we can write given the information we have currently. So one of them could be, I'll start with the x1, y1 point. So my first equation could be y minus 2. So I took my y1 point equals 3 times x minus 3. There we go. There's our first equation. Or I could keep, my slope's not going to change, but I could plug in my other point. So I could say, or y minus 8 is equal to 3 times x minus 5. So again, you're just plugging in a coordinate point for x1, y1 in here, and then plugging in your slope that you just solved for, and you have an equation in point slope form. This is a perfectly valid equation. You could stop here if it asked you for just an equation of a line and you'd get the answer correct. But oftentimes they'll ask for a next step. So we're going to go over transforming point slope into standard form in just a second, but make sure you jot down any questions you have about the process here before we move on. All right, so the next example I want us to do together is writing an equation and from points or transforming an equation from point slope form into standard form. So we're going to start with this equation, y minus 2 equals 3 over 4 x minus 5, and I want us to write it in standard form. So the first thing we're going to do, step 1, we have our equation written here. There's a couple things you can do, but I'm going to teach you to do this step first because I think it'll make a lot of your lives easier and avoid a lot of errors. So since our slope in this example is a fraction, we're going to first step get rid of fractions. In our slope. If we're starting with a fraction in our slope, our first step is going to be to get rid of it because I know a lot of you don't like working with fractions, so let's get rid of it. And to do that, I'm going to multiply by the denominator. On both sides. So to do that, I'm going to take this and multiply by 4 and this whole side multiplied by 4. So now I have 4 times y minus 2 is equal to, since I'm multiplying 3 over 4 by 4, the 4, I'm multiplying and dividing by it, so it cancels out. So when I'm multiplying the whole side by 4, I'm canceling the one I'm dividing by multiplying, so I'm left with just 3 times x minus 5. And now this is going to be a lot easier to simplify, and I won't have to worry about getting a positive number or to getting a whole number at the end because I've already gotten rid of my fractions. So step 2 is going to be to distribute. So I'm going to distribute in here. I have 4y minus 8, because that's a 2, equals 3x minus 15. And then I'm going to move or subtract from both sides. So minus 3x, and I have negative 3x plus 4y, or minus 8 equals negative 15. I'm going to add 8 to both sides. So I add 8 to both sides, and I have negative 3x plus 4y equals negative 7. Negative 15 plus 8 is negative 7. And this satisfies your book's requirements for standard form, but oftentimes teachers will want x to be or the coefficient of x to be positive, so you can also multiply both sides by negative 1. So when I multiply both sides by negative 1, I'm going to do this. So then I'm going to distribute my negative 1 in, and negative 1 times negative 3 is positive 3x. Negative 1 times negative 4y is negative 4y. Negative 7 times negative 1 is positive 7. So this would be my standard form equation. So the main keys is to first get rid of your denominator in your fraction by multiplying both sides by the denominator. So I multiplied by 4. Then I distribute and move the variables to one side and the constant to the other, and then simplify my equations, multiply by negative 1 if necessary. So I know that's a lot of information, and I'm sure some of you are a little confused. So let's do a quick check together. I want you to do the same thing, rewrite this in standard form, but we're going to start with y minus 3 is equal to 4 over 5, x minus 2. So go ahead and try that on your own, pause the video, give it a shot. I'm going to go over it now, so if you haven't finished, pause it. I'm going to start by multiplying both sides by 5, so I'm going to do 5 times y minus 3 equals 4 over 5 times x minus 2, all of that times 5. So the 5's there cancel, and I'm left with 5 times y minus 3 is equal to 4 times x minus 2. Now I distribute in on both sides, and I have 5y minus 15 equals 4x minus 8. I'm going to subtract 4x from both sides. So my variables are both on the same side. And then I'm going to add 15 to both sides so that my constants are on the other side. And negative 8 plus 15 is positive 7. And my last step, since I want x to be positive, will be to multiply both sides by negative 1. So I distribute my negative 1 in, and I get positive 4x minus 5y is equal to negative 7. And that is my solution in standard form. Make sure you write down any questions, comments, concerns, or clarifications you have on any of the work I just did so we can go over them together. There's one last thing I want to go over briefly with you all, and that's solving for intercepts. So one thing that standard form is useful for is solving for your intercepts. So x and y intercepts, just to make sure we're all clear on what our x and y intercepts are. If our x-axis is here, our y-axis is there, say we had a linear function like this point right here is my y-intercept because it's crossing the y-axis. This point right here is my x-intercept because it's crossing my x-axis. And I'm going to make a note here. This is going to be useful for all sorts of functions that we learn about throughout math. When you're solving for your x-intercept, you are just going to substitute y equals 0, or 0 for y. So whenever you're solving for your x-intercept, y is 0. So if we look here, our x-intercept is on the x-axis. It makes sense that y is 0 because everything above the x-axis in y is positive, everything below the x-axis for y is negative. So anywhere along the x-axis, y is going to be 0. That will always be true. So y is always, 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 always 0 on your x-axis. And similarly, x is always going to be 0 on your y-axis. So you solve for your y-intercept by substituting x equals 0. So if we have a standard form equation, we'll do an example. If I asked you what are the intercepts of 3x plus 5y equals 15? That's a question mark. So if I asked you what are the intercepts there, all you're going to do, step 1, you solve for the x-intercept by substituting or plugging in y equals 0. So solving for my x-intercept, I have 3x plus 5 times 0 equals 15. I simplify, 5 times 0 is 0, so I'm left with 3x is equal to 15. So x will be equal to 5 because I divide both sides by 3 and I get x equals 5. So my x-intercept is going to be the coordinate point. X would be 5, and then y, what I plugged in for y is 0, so my x-intercept is 5, 0. So I substitute for 0 and solve for x. And now to solve for my y-intercept, I'm going to do the same thing, but substituting 0 for x. So I'm going to solve for the y-intercept by substituting x equals 0. So in this case, I'm going to have 3 times 0 plus 5y equals 15. 3 times 0 is 0, so I have 5y equals 15. So y would be equal to 3 when I divide both sides by 5. So my coordinate point for my y-intercept is going to be 0, because that's what I plugged in for x, comma 3. So all I did there was solve for y. So that's all our notes for today. Make sure you write down any questions, comments, concerns you have on this so we can go over it together in class.